In this class, we're going to go over what are covalent bonds and how do they form. First of all, remember that elements join to be more stable and less reactive by interacting with the valence electrons depending on their electronegativity. Nonmetals are known for having a higher electronegativity than most of the other elements, which means that they attract the valence electrons of the neighbor atoms. If you consider both bonding electrons to be nonmetals, both are trying to attract the valence electrons of the other. So, in the end, it creates a shared space or orbital where the two have those electrons that they're going to fight over. So we call that a covalent bond. Covalent bonds then are defined like the sharing of electrons between two atoms. They can be classified by the number of electrons that they share into single, double, or triple. And then they can also be classified by the difference of electronegativity between the atoms involved into polar bonds or nonpolar bonds. When several atoms are joined together by covalent bonds, the group that they form is called a molecule. It is important to mention that the number of electrons has remained the same, so therefore, this group is neutral. Now, molecules can be of the same kind of atoms, like you see in the picture. There's a picture of an oxygen molecule, and that's an elemental molecule or diatomic molecule. And molecules can also make substances or compounds, like the water molecules that you have in the picture right there. Now, regarding the polarity, like what is polarity? The word polarity refers to the existence of poles, in this case, two, a positive and a negative. Although these poles are not real charges, because they depend on the motion of electrons between the two atoms at a moment of time, we refer to them as relative charges. And we use the Greek letter delta, as you see right there, with the charge or partial charge that they will acquire, positive or negative. The negative side is for those ones that have the electrons more time with them because they're higher electronegativity, and the positive side is because the electrons are closer to the other side. Now, polar bond is going to be considered when the difference of electronegativity varies between zero point 0.5 and 1.7, 1.9 approximately. And when you don't have values to consult, then you have to consult the place in the periodic table considering the trends as we saw before. In a molecule made out of two atoms, like the one shown in the picture, the polarity of the bond will determine the polarity of the molecule. But when you have a molecule that it has way more than two atoms, then you have to consider the shape that the molecule will take, and that's a topic for another time. We draw or show how covalent bonds are formed by using Lewis dot structures or by using what we call structural formulas. In a Lewis dot structure, we can put the electrons as different shapes, little shapes, so that we can identify when they're bonded, like you can see the example, or we can do it by structural formulas where the shared electrons become a line. One important thing to mention is that the electrons that are not part of the bond are called unshared pairs. These will become important later on when we determine the shape of the molecule, because these ones will be the ones that determine that. Now, for the difference between ionic and covalent compounds, we have this table right there that you can look at. Ionic compounds don't make molecules, they make crystals, whereas in the case of covalent bonds, they make molecules. The bond between two ions is an electrostatic force where opposites attract. And in the case of a covalent compound, the molecules formed are sharing the electrons. The combinations of elements are different. In an ionic compound or bond, we have a metal with a non-metal, or a metal has to be involved because those are the ones that will lose the electrons, so a transference can happen. In a covalent bond, we have a combination of nonmetals. Also, the characteristics of the compounds vary because ionic compounds are mostly solids, definitely solids at room temperature, and in covalent compounds, we have mostly gases and liquids, where the melting points would tell us what kind of substances they are. So that's it for today for covalent compounds and bonds.